right? So we're going to start out kinesthetically. That means physically do it. I want everybody to give me an absolute value with their arms. Everybody stretch, give me that absolute value. Now, what happens if I come around and I take your arms and I vertically stretch them? Pretend I'm stretching all your arms right now. What's going to happen to your arms if I'm pulling them up? What's going to happen to the picture? Yeah, it's going to be like here, it's going to get thinner. This is a stretch, vertical stretch. Okay, shake it out. All right, give me another absolute value. Now I'm going to vertically shrink them. So vertically shrinking. What's happening to your absolute value? Wider. So absolute value, vertical stretch is skinnier, vertical shrink is wider. What does this to your absolute value? A reflection is what it's doing, but what in the equation does? A negative sign. And you would say reflect to the x-axis, but it's the negative that does it. So when we're multiplying by a number, it either skinnies it or widens. And we know, and we've already gone over this, we know that it's going to make it a vertical stretch if the number is greater than 1, or it's going to be a vertical shrink if the number is between 0 and 1, like a half. If the number is negative, then there's a reflection and a stretch or shrink. There's two transformations if it's negative. Now we have not done horizontal stretch or shrink yet. So this is new. We're going to do absolute value again because it's easy for me to do absolute value. Everybody give me an absolute value. And now I'm going to come over and I'm going to grab your hands and horizontally, I'm going to stretch them. Think I'm pulling your arms out horizontally. What's going to happen to the V shape? It's getting wider. So a horizontal stretch is going to go wider, where a vertical stretch goes skinnier. So you have to think about which direction I'm pulling your arms. Horizontal will be wider. How about a horizontal shrink? Give me absolute value. Absolute value. Absolute value. And I'm going to shrink it horizontally. Horizontal shrink. Horizontal shrink. I'm pushing your arms in horizontally. What does that do? It's skinnier. It's thinner. So like the vertical and the horizontal are like completely opposite of each other. Vertical stretch, horizontal shrink. They're the same. Horizontal stretch, vertical shrink. You got to think about vertical shrink, horizontal shrink, like you got to think those. Since it is horizontal, you will find the number inside of the function. Inside of the function because it's horizontal. Because it's horizontal, the inside of the function. Also, every single time we have horizontal, we do the opposite operation. And I'm going to use one of those little graphs just to explain this opposite operation thing. So I'm going to use this top one here that says y equals negative 4x. I'm going to use that one just to explain opposite operation. I don't know what I just said. Absolute value 4x. That's the one I'm using. Absolute value 4x. So you look inside and you see inside of the absolute value, it's being multiplied by 4. So that means it's horizontal because it's on the inside. And because we're multiplying, it's going to be a stretch or shrink. Because it's a 4 multiplied by 4, we do the opposite. Because it's a multiplied by 4, opposite of multiply by 4 is what? The opposite operation of multiply by 4. Divide by 4. But occasionally we're going to get fractions. So I'm going to think of this a different way. I'm not going to think like divide by 4. Instead of dividing by a number, instead of dividing by a number, can you complete my sentence? Instead of dividing by a number, multiply by the reciprocal. Gold star. So when I see something like, of course I wrote too big, now I can't go back up to the equation. When I see this equation, there you go, y equals absolute value 4x, I see that 4 in there. What I'm actually going to multiply by is 1/4, which makes this a horizontal shrink, because I'm going to be multiplying by 1/4. That's going to get smaller. So horizontal shrink, if I were going to shrink your absolute value, what would that do to my arms? Shrink it horizontally. I'm going to push those arms in. That's horizontally shrinking them. So if you look at the picture, you can see the red one is the last one, and it was pushed in from the blue one in that picture. You don't have colors on yours, but you can see that y equals absolute value 4x is way skinnier than the y equals just absolute value x. All right, this would be the most challenging part of this whole thing, is remembering that we always do horizontal opposite. But I promise to get it if you practice. I had no problems with people understanding it later in the year last year. It's just right at the beginning, it's a little tricky. So today we're going to be writing equations, just like we were doing yesterday, but this time we're going to have stretches and shrinks in it as well. So we read, by the way, the take note just talks about if there's a negative next to a number, that is a reflection and a stretch or shrink, which I already said. That's what that take note is. Example A, write a function g whose graph is a horizontal shrink of the graph of f by a factor of 1/3. So f of x is absolute value x minus 3 minus 5. So this is the original. What's going to happen to the transformed? This horizontal shrink. So I'm going to take it and I'm going to push my arms in. So horizontally it's going to shrink, and yes, it's going to get skinnier. But we're not actually graphing this. We're going to find the equation. You could check it on your graphing calculator to make sure you're doing it right. So what's the name of my equation? What name? G. See, there's the G, G of x. It will tell you what name to use. Whose graph is a horizontal shrink of the factor, shrink of the graph of f by a factor of 1/3. So if it is a horizontal, that means on the inside. So I'm going to write f of, and on the inside, I'm going to multiply a number with x. But that number is opposite of what I'm multiplying by here. So if I'm multiplying by 1/3 in the question, what actually goes in there? 3, the reciprocal. So that is the function notation, like I was starting out yesterday. Then we're going to take this, and wherever you see, when we do this kind, this is a replace. Wherever you see an x, we replace it with 3x. That's what this means. When it's f of, that means wherever you see an x, make it 3x. So with our g of x equation, we look at the f of x equation, and the first thing is an absolute value. Then I have an x. But I'm going to replace that x with what? 3x. Then I have a minus 3. I have an absolute value. Then I have a minus 5. So I replace the x with 3x. And that's it. There's nothing really else to do for that one. So another example. Write a function h whose graph is a vertical stretch of the graph of f by a factor of 2. So what's the name of my function? And then we are talking vertical here. And if it's vertical, it goes on the outside of the function. Outside of the function. So this factor is 2. Do I have to change it for vertical? Only for horizontal. So this is vertical. I don't have to change it at all. It's still a factor of 2. And it's going to be multiplied on the outside of f of x. So I'm going to have 2 f of x. So then you guys should know what f of x is. It's in the directions. So we're going to write h of x equals 2 parentheses. Now I need to go look in what f of x was. X, absolute value x minus 3 and then minus 5. Absolute value x minus 3, close absolute value minus 5. Do you see how I'm multiplying 2 by the entire function? How can you tell it's the entire function? The parentheses say that's the entire function. So since there's more than one term in this function, we do have to distribute the 2. You are going to simplify it. And when you multiply a 2 or any number with the absolute value, you don't go inside the absolute value. You just put it outside the front of it. So 2 absolute value x minus 3, close absolute value, and then minus 2 times 5 is 10. So you do have to distribute that and simplify it. So can you tell the difference? The first one, the horizontal, we're just taking out x and putting something new in. But the vertical, you're going to have to multiply everything by that number. The next two say student practice, but we're still going to do it together. You can work ahead for like, I don't know, 30 seconds. See if you know what to do. Use these examples to do the next two examples. They are very similar. And just have different equations, but they're very similar. See if you can follow the work on A to do question 5. But I will go over it. So I'm going to give you the opportunity to try it first. So this one's not right, and you're not showing all that work that I showed. Do you want me to put it back up on page 4 so you can get it? There's something wrong about that one. If you guys do not write down all of your notes, if you just put the answer, you're going to have nothing to go back and look at to see how you got that answer. I think the note taking and modeling in class, that's where you're going to learn the best. Number 5. So this is horizontal, so it's on the inside, right? But also, what do we have to do with horizontal? The side's just on the inside. What also did I do? All right, so the first one horizontal. If you didn't get done with it, I'm going over it because a lot of people have the same mistake over and over again. The first one says horizontal. If it's horizontal, where is it located? And you all are doing that. That, for the most part, I thought was right. But it also means it's the opposite operation. So I'm going to have g of x equals f of something multiplied by x. But that, what I'm multiplying by, can't be 2. It has to be the reciprocal, because we have to do the opposite operation. It's 1/2. So that's where I saw a lot of people put 2x in the parentheses instead. Then we'll go ahead and, this is the kind where you replace x with half x. So in this equation, I'm going to replace x with half x. So I have g of x equals 4. I'm going to replace it, half x. And then I still bring down that plus 2. That plus 2 didn't have any x in it. So you just bring it down. And then you ask yourself, is there something we can simplify? 4 times a half. Oops. Where'd you go? Seriously. Come back. So g of x equals 2x plus 2. If you did it correctly, that's what you get. All right, take 10, 15 seconds on this one. See if you can figure that one out. It's just like question B from my examples. I'm obsessed with them. I have erasable pens and markers. They really work. They're a little bit more expensive, but they totally work. I just make a lot of mistakes. Okay, let's see if you're on the right track. If you didn't finish it, that's okay. See if you're on the right track. So I'm going to name it g of x. By the way, how did I know what to name it? It doesn't say anything right here. Oh yeah, you got to read these directions up here. That's very good. Okay. G of x, and then this is a vertical shrink by a factor of 1/3. So 1/3 is the vertical shrink. Vertical means where? Outside. And since it's vertical, we don't even change it. So we're going to take 1/3, we're going to put it outside of f of x. So g of x equals g of x equals 1/3 parenthesis my absolute value x minus 3 close parenthesis. Can we simplify that? Yes, you can multiply our 1/3 through with the distributive property. You get 1/3 absolute value of x minus, then we have to do 1/3 and multiply it by 3. So you got to go straight across. You get 3 over 3, which reduces to 1. That's it. Trying to save you $400 here. All right, the next is going to be multiple transformations in one question. So we're going to have multiple steps. So you just want to stay organized. And you want to ask questions if you're not understanding where I'm getting something. By the way, if you do get tired, I know like the period after lunch, I have the lights down low. It may be challenging for some of us. I do not mind if you want to stand at the counter or if you want to use one of the back chairs, like stand and do notes, because you're going to fall asleep less if you're standing than, you know, in my little cushions that I bought for you. Maybe I shouldn't have done that. All right. Example 5, combining transformations. Let the graph of G be a vertical shrink by a factor of 0.25, followed by a translation 3 units up of the graph of f of x equals x. Write the rule for G. There's multiple stuff happening, so you need to stay organized. First thing I want you to do is kind of like figure out where it says followed by, and right above that, let's write simplify. That followed by, or that simplify, divides up the steps into the first step and the second step. So you have to go in order. If you go out of order, you possibly get the wrong answer. So we're going to go with the first part. And I'm going to use color so you can kind of see between the two different parts. Vertical shrink by a factor of 0.25. This is to get G. Actually, let me go backwards. This is not to get G yet. This is only half of it. I still have to do something else for G. So I'm going to make up an in-between equation. So f of x is that equation. The answer should be g of x. I'm just going to call this in-between like an h of x. It's that in-between. I'm just going to call it h of x. It's a different equation. It says a vertical shrink by a factor of 0.25. So we do that on the outside of the function. So I go 0.25 multiplied by f of x. Then I go and I look what f of x is. And it's an easy one to start. We multiply that by, what's f of x? What's f of x? X. So I just plug that in because that's what it equals. And then we simplify. So h of x equals 0.25. I don't need the parentheses. So there you go. Simplified it. Sometimes you simplify more than that. That is not my final answer. That's h of x. That's kind of the halfway there answer. Get it? H is halfway there. I just made that up. So now we need to go do the second part. And this will be our g function. Once I complete that second part, this will be our g function. It says now we need to do translation 3 units up. But that 3 units up has to go off of the h of x function. We first shrank it. Now we're going to go up. So I'm going to start with my h of x function, this one here. And to go up, I add 3. So I'm starting with the previous function, add 3. So g of x, what is my previous function? 0.25x, add 3. Then I say, can I combine anything? Is this simple in this form, or is there some, could I add those together? Yeah. So then that would be it. That one's a pretty easy one. So we're doing halfway there, then we're finishing it with the second part. Evan, you want to come closer? There's two closer seats that'll help you see a little bit better. If you forget your glasses. My son forgets his all the time. He just got them. Like he got his first pair of glasses this time. All right. So student practice, we'll do it together as well. First thing you want to do is find the word followed by. Find that followed by. Look for followed by. Here it is. That's going to be a simplified step in the middle. So before followed by is going to be our h, our halfway. So this says h of x, what's it say? Translation 6 units down. So down is vertical. I'm going to take my f of x function and subtract 6. What is my f of x function? So h of x equals absolute value of x, subtract 6. Can we simplify that at all? No, that's simplified. So then we move on to the second part, which is a reflection in the x-axis. But it's going to go off of this first part. So I'm going to take this part and add do something to that one. So our g of x is going to be a reflection in the x-axis. So this is where you might need to kinesthetically figure out what I'm talking about here. If we reflect in the x-axis, then you pull out your x-axis, and you take something, and you reflect it over the x-axis. What direction am I reflecting? Horizontally or vertically? Vertically, right? Like saying the x-axis makes you think horizontal, but when I reflect, it's vertical reflection. So this is vertical. That means on the outside of the previous function. On the outside of the previous function. So our previous function is absolute value of x minus 6. So we're going to do negative parentheses, absolute value of x minus 6, close parentheses. Can that be simplified? We can distribute our negative sign, and we get g of x equals negative absolute value of x, and then negative negative plus 6. I have to change both signs. Notice how it did not go into the absolute value. Just stayed in front. Okay, then our very last example is just a real-life example using transformations. You design a computer game, and your revenue for X downloads, that's the number of downloads, is given by f of x equals 2x. Your profit is $50 less than 90% of the revenue for X downloads. So revenue is just all the money that you take in, but profit would be after you pay for whatever expenses you have. Profit's like the money that you get to take home. Revenue is money that comes in, profit you take home. So the question is, how do you write the equation for profit, and then what's your profit for 100 downloads? So I'm going to call my profit equation P of x. Let's call that P of x because it stands for profit. This is revenue right here. To get profit, you do $50 less than 90%. So when you read that, it says take 90% first, then do $50 less, even though it's written in that order. So we have to do 90%. That is a multiplication. And remember, 90% is written as 90 over 100, or 0.9. That's going to multiply by f of x, 2x. Then we subtract $50. So there's a stretch, and there's a translate down $50 from your revenue. Not a stretch, a shrink. This is a shrink, it's getting smaller. So then we can simplify that, and what's 9 times 2? 18, so 0.9 times 2 is 1.8. And so we have our our profit function. And then it says, what is your profit for 100 downloads? So what up here represents the number of downloads? So that means we're going to plug in 100 for x. So we will have 180 minus 50 equals $130 profit. So your assignment is very similar to that. It is in the book right now, but when you get home, you can plug it into Big Ideas. I don't have a computer card, so you can't do it right now. But right now, do you see how everybody has a book on there at their desk, except for, I don't know where your book went. I'll have to get you one. Hope somebody didn't take it. So you're going to open up the book to page, it's actually 16. Do you need a book? Here, why not this other guy? If we need more, I can do another one. Is there one of those sets? Here's one. So open up the book to page 16, 17. I wrote 17. It's actually 16. Yeah. And you're going to have to do this on paper. You can't really do big ideas on your phone. Very few people can do it. It gets all messed up. So you'll have to plug these in like at home, or you can come in during or XH tomorrow if you want to type them in at school. You have to do it on paper to start. So it's the exact same questions on paper as it is in the books. You're not doing anything extra except for you're making sure you're writing it down. That's all. I should not see Snapchatting or texting or any goofing around on the phone right now. We have some time to actually start our assignment, which we don't have very often here. So start it so I can help you. I know that some of you are going to have questions. I know that there's going to be some questions. Numbers are here. It's the exact same numbers that are on Big Ideas. It's just I don't have the computer part, so you'll have to do it later. Sorry. But you'll be able to check your answers to see if they're right when you plug them in. You'll also be able to ask me questions right now while you're here. And then I'm going to hand back some papers as well while you're working on it. I'll call you. I updated Hack. You can see what your grade is in here. Okay. Gina, do you want to come up and get your papers here? It's just going to go in alphabetical order, so Cameron goes in. There you go. Cameron? Taylor? Taylor, I have a missing assignment for you. Is that true? You know? Yeah, what? Order? And you can also check on that to see if I entered your grade. I can check on that. If I didn't enter your grade, potentially you forgot to check on it. And you'll grade it and then pass it to the right, but I don't have it. That one I didn't move back to it. Or maybe that. No, that one I didn't move back to. So look and see if you still have it. Okay. Page. I don't know if you're where for you. Bryant. Come here. If you ever get this low, it would be better if you could turn it in late and get like half credit off and turn it in with more points than it would be to just turn it in and only get 5 out of. There you go. Just for the future. Okay. Morgan Keller. Liv. Thank you so much for putting like Liv, what you want to be called. That's how I remember your name, whatever you write down. Morgan, listening. Regina. Lena. Manuel. Ethan. H. Allison, Allie. Right? Go by Allie. Allison, Allie.
It's Bauer.
You can put Allison on your paper, that's what we'll call you if you want to. What is it, sales or Allie? I'm not looking at my list from the first day, but, yeah, whatever you want to be called, you can write on the paper. That's how I kind of really learned it the best. Edwin! Edwin on this one, like, we learned this and we scribbled it out, so I didn't know what your score was, so it looks like it's a 0 right now. If you can count up the number of points you got, put it, then we can figure out your percent for me. Or, these are gonna be less than 50. Why don't you finish it and turn it in like tomorrow or the next day, and then you could get half up, but it's gonna be higher than that grade. All right? Andrew? Easley? Julia? Yeah, can you write them? I think everybody's getting migraines and allergies today, like everything. All right, where am I? Molly. And Kylie. All right, so you guys are working on your assignment. If you have questions, ask me. I'd like to help. So what are we doing with this 12,000? What do you think? So we need to mix it up. Okay, so I start at $0. And I pay 12,000. How much money do I have now? So you need to have a minus 12,000. And then what's happening every week? Are we multiplying by negative 12,000 each week? What's happening in this situation? What's happening in the development? Okay, so per week, you get 6 weeks. So after 1 week, you would get paid $12,000. Which, how's that going to affect the negative 12,000 that you're sitting here now? So what's it going to do? What operation? That's not multiplication. What operation is that? You're going to take away 4,000 each week? year to go less than. No, that needs to be going up, right? So what do you think what operation? So this big idea that you're doing tonight, it is the exact same question, 10, 17, 22, 27, 32. You're just doing it on paper in class. Or does it work on your phone? That's good. Some people it doesn't work on the phone. What kind of phone do you have? It's working on Morgan Keller's iPhone. So it might work on your iPhone. Just not it doesn't work on everybody's. Oh, I have a computer. Forgot. Seems like it was like 2 hours ago I had that conversation. So you have to log in and then you can just hit submit before you do it. Who else needed to submit it? Oh, shoot. And when you sign on, make sure it's you, because sometimes people in the bell before don't sign out correctly. Just have to make sure it says your name in the corner. Okay, so you have a business, a cafe, and then it says this is what you're going to be making, $4,000 per X. What that means. Okay, so per week you should be bringing in $4,000. But to set up the shop, you had to pay $12,000. So you started at $0, paid $12,000. Where are you sitting now? If you start with $0 and you set up your shop and just pay $12,000 to get it all pretty, how much money you got? You were at 0 and you paid money. That's how much you paid. How much money you got in your year? Here's my money. See right now it's 0. Now I'm going to pay $12,000. What's going to happen with my money? If I'm paying $12,000, I have nothing there. Yeah, you're going to like start in the hole, and then you're going to be making $4,000 per week after that. You start at making $4,000. Well, that's anything before you start. It's not working? So you did? Okay. Leave the books here, don't take them with you. Don't take my books. Take them on the desk. Take them there. Don't take them. Have a great day. Don't take the books. Have a wonderful day. Okay, 10 minutes. Did you put it in the mailbox? Glenn? Did you put it in the mailbox?
Yeah. Sides.
10 minutes.
Or just down.
Why don't we go down here? I brought my calculator.
Oh! We also watch lunch.
To check your answers possibly.
I'm gonna just borrow it.
Oh my gosh, I'm still recording. For the last though.
I thought it was us.